we need to start thinking spring. April is here. Despite its widespread popularity as a northern game fish, the muskellunge faces an uncertain future. In many areas where the species once maintained healthy natural populations, it has been extirpated or is sustained only through artificial propagation and stocking. Several hypotheses have been advanced to account for this decline. I need the lights on the podium, please. Several hypotheses have been advanced to account for this decline. First, the competitive superiority of the northern pike. Second, overharvest due to heavy exploitation and inadequate regulations. And third, reproductive failure due to loss or modification of habitat. Muskellunge management strategies commonly include the stocking of hatchery-reared fingerlings or fry. Over the long term, a more desirable management approach might be to identify ecological factors contributing to the species decline, followed by corrective measures. These considerations suggest that a descriptive community analysis of muskellunge waters might provide valuable information concerning ecological requirements of the species, especially those related to natural reproduction. Our study attempted to identify ecological factors affecting natural reproduction of muskellunge. At the onset, we didn't realize that interaction, particularly interaction with northern pike, was going to be a predominant theme of this study. Well, at any rate, how does one approach such a problem? Of course, there's the intensive case study approach, which can generally be confirmed by doing long-term labor-intensive studies, and for this reason, they're often low priority, especially in such economically austere times. It's a desirable approach, but keep in mind that resource management doesn't wait for answers. An alternative approach is to perform statistical analyses on the extensive database which exists in resource agency files. There are disadvantages to this approach as well, since these data have been collected by different biologists at different times, in some cases using different methods. However, on the positive side, the data are readily available, require no additional field work, and are inexpensive to get. In addition, such data cover a broad geographic range over time and may point out trends that intensive case studies miss because of local conditions. Ecological data were obtained from the respective Department of Natural Resource Agency survey files on 117 selected lakes within Forest Service Region 9 in Michigan, Minnesota, and Wisconsin. Lakes were selected based upon the availability and completeness of ecological information and their occurrence within the muskellunge's native range. Lakes included, as shown here, occur within 6 major drainages: the Upper Mississippi, the Chippewa, the St. Croix, and Wisconsin rivers, and lakes Michigan and Superior. Estimates of the level of natural muskellunge reproduction from each lake were obtained from DNR fisheries biologists. For statistical purposes, each lake was placed into one of 5 discrete groups, each group representing a manager estimated level of natural reproduction as little or none, poor, low, moderate, and high or self-sustaining. In the subsequent analyses, the discrete level of natural reproduction was the dependent variable. The data compiled represented 5 general ecological categories. First, 43 fish species abundance rankings as rare, common, or abundant. Second, 10 lake morphometry variables such as mean depth, lake size, and percent littoral zone. Third, 5 water quality variables such as pH and alkalinity. Fourth, 31 watershed features including watershed area, outlet volume, water source as drainage, seepage, or spring lake, and spring water level condition as stabilized or rising. And lastly, 5 cultural influences such as the number of resorts, number of dwellings on each lake. Using these data then, we began to utilize statistical procedures to obtain answers to a series of questions. First, what ecological factors are related to muskellunge reproduction? Analysis of variance was used to test for significant relationships between the level of muskellunge reproduction in each of the 94 variables. Note here that northern pike abundance was identified as one of the 9 variables significantly related to muskellunge reproduction. Now that these variables had been identified, we wanted to know the direction of the relationship. For this, we used correlation analysis. Note that the correlation coefficients between northern pike abundance and level of muskellunge reproduction shown here in the box is a negative 0.21, significant to the 0.05 level. For purposes of interpretation, correlation coefficients range from +1 to -1, 0 being no relationship. Therefore, this is not an overly strong relationship, but it does suggest the influence of northern pike on muskellunge reproduction. The next question was to determine what combination of the 9 ecological variables best explain the variability in muskellunge reproductive levels. We used stepwise multiple linear regression analysis, and note here that of the 9 variables, northern pike came out as the predominant factor, contributing 41.7% of the variability in muskellunge reproduction, whereas all 9 variables in total accounted for 57.4% of the variability with muskie reproduction. We wondered why multiple regression identified pike as the overwhelming influencing factor, while correlation analysis did not. Keep in mind that correlation was negative 0.21. We are also aware that muskies and northern pike do coexist in lakes such as Leech Lake, Minnesota, Eagle Lake, Ontario. Well, so this brought on a new series of questions. Apparently, other factors influence the interaction of the two, other ecological factors influence the interaction of the two species. So we began asking other questions. First of all, are there differences in the influence between pike and muskies in different drainage basins? Note again the negative 0.21 for all drainages. When we look at Lake Superior, we see a strongly negative relationship of negative 0.96. St. Croix River drainage, negative 0.73. Chippewa River drainage, negative 0.64. Lake Michigan drainage, negative 0.62. All highly significant relationships, whereas we found no relationship in the Wisconsin River drainage or the Mississippi River drainage. It was at this point that we realized other factors were playing a role here, and now we start asking questions concerning what these factors might be. For example, what ecological factors influence muskellunge reproduction, the northern pike abundance interaction? Our procedure was first to organize the 117 lakes according to 4 combinations of muskellunge reproductive success and pike abundance. Each box on this slide represents one group of lakes. The box on the upper left represents lakes having good muskie reproduction with northern pike abundance. On the upper right, we have low muskie reproduction with high pike numbers. The green box on the lower left, we have lakes with high muskie reproduction and low pike numbers. And lastly, in pink on the lower right, we have poor muskie reproduction and low pike numbers. Keep this scheme in mind. I'll be referring to it again and again here in this talk. Next, using analysis of variance on the 4 combinations, we asked which of the 94 ecological parameters were associated with the interaction or association of these 2 species. The results showed that 12 parameters in 4 of the 5 broad ecological categories were associated with this interaction. Since this is a long and time-consuming story, I won't discuss each variable in detail, but we'll take a look at the broad ecological categories. First, lake morphometry. Note in the upper left, we have our good muskie lakes and our good pike lakes. They're the largest lakes and the deepest lakes. While on the lower right, we have the poor saucid lakes, which are the smallest. With regard to water quality, lakes where the two species coexist are hard water lakes having the highest alkalinities and pHs, while lakes where either the Muskie or the Pike predominate have near intermediate alkalinities and near neutral pHs, and lakes having the lowest alkalinities were the poorest isocid lakes. Keep in mind that the difference between one pH point, for example 8.3 to 7.3, represents a tenfold difference. Water hardness is a particularly interesting feature, since this aquatic plant called Cara or muskgrass grows in hard water lakes. You may recall it was mentioned yesterday by both Bob Strand, where it occurs in Leech Lake, and also by Craig and Black, it occurs in Georgian Bay. Cara apparently provides suitable spawning habitat for muskies, and it may be associated with the segregation of the two species at the time of spawning. Some watershed features related to the association of the two species are shown here. Lakes where the two coexist generally have rising springtime water levels, are most often drainage lakes, and have the highest outlet volume, being associated with large river systems. We speculate that these features may also facilitate the separation of muskie and pike during the critical spawning and early life stages, as some other studies have indicated. The muskellunge appears to be more sensitive to human development than the pike. Note here that lakes with good muskie reproduction have the lowest cultural and agricultural development, as depicted in the two boxes on the left. On the other hand, pike abundance is high for both high and low levels of cultural developments. Based upon our own work and the research of others, we hypothesize that the muskellunge is best adapted for reproduction in oligotrophic waters associated with large river systems. As lakes become enriched or polluted, the balance is tipped in favor of the pike. And of course, beyond that stage, there is a point where even the pike is unable to reproduce successfully. In summary, then, muskellunge and pike do best together in large, hard water drainage lakes with rising springtime water levels and minimal human influences. Where ecological conditions do not exist, it is likely that the northern pike will predominate over the muskellunge when the two species occur together. Are there any questions?
Mike, you talked about Cara contributing to segregating the two species at spawning. What do you mean by that? Can you elaborate on that a little bit?
Well, this is largely based on what we've seen in going on in Leech Lake. Had Bob Strand had more time, he would have elaborated that the Cara beds grow out in open water, and what he's seeing there is muskellunge spawning out in these open water areas, long distances from shoreline, but yet the northern pike are utilizing traditional muskie spawning, what would be typical Wisconsin or Michigan-like muskie spawning areas in the shallows. So it appears based on that the two species are separated. The muskies are attracted to the Cara. Also, there are several upper Michigan lakes where we have good muskie reproduction, and Cara is the predominant vegetation in those lakes. Mm-hmm.
Have you evaluated some of the smaller lakes with inflows of water? Is that any importance to staying muskie spawning in those?
The question was, have we evaluated smaller inland lakes with water with influent streams and how that influences muskellunge reproduction? The lake size, as indicated, seems to be a major factor influencing this, and if lakes are too small, it appears that there just isn't enough space for the two species to separate during, say, a time of reproduction, and I know of no small lakes where the two species occur together. It's usually the northern pike that eventually predominates. But yet, if pike are absent, muskies will do well in small lakes, or smaller lakes.
Thank you, Mike. Mike is an ideal speaker to have to start off. He picked up time that was lost to the door.